Hello, calculus fans. Okay, so let's try to mix a couple of our concepts here. We're going to try to compute y prime, and it's for the function that's defined implicitly by y arc secant of x is equal to y to the fourth. So this requires knowing some derivatives of inverse trig functions, but it also requires us to use some of our implicit differentiation. Now, one of the things we're going to need here is the derivative of the inverse secant function. So we've talked about inverse sine, inverse cosine, inverse tangent. We haven't given the formula for the inverse secant. So what we're going to do here is I'm just going to give you the formula, and I'm going to leave the derivation for the homework. And it's going to be essentially just like the derivation of arc sine, arc cosine, arc tangent. So you'll have to work that out. Okay, here's the formula. The derivative of arc secant of x is 1 over x times the square root of x squared minus 1. And I'd like you to have this memorized along with the derivatives of arc sine and arc tangent. That's pretty much the end of our derivatives that we need to have memorized. We're going to have one more. That's when we get into the next section. But we're getting to the end of the memorization that we have to have. Let's go on to computing the derivative. We're going to do that by implicit differentiation. That's because in the original equation, it's difficult or really impossible to solve for y to try to solve that directly. All right, so we're going to compute these derivatives with respect to x on both sides. On the left side, we're going to have to use the product rule. On the right side, we just use the power rule. So you should be able to see on the right side, that's pretty straightforward. We just use the power rule combined with the chain rule because we're differentiating something that's got an inside function. As usual, we have to think of y as being the inside function here. Now on the left side, we use the product rule. So we're doing first times the derivative of the second plus the second times the derivative of the first. Notice that the derivative of the first, that's the dy by dx, and then now we're going to have to put in the derivative of the arc secant function that we had shown up here. Okay, so if we put that into place, we'll have 1 over x times square root of x minus 1 there. So that's replacing this with this guy here. Now we have to keep in mind what our goal is. Our goal is to solve for dy by dx. So we need to get all the terms with dy by dx on one side, everything that doesn't have it on the other. Let's see, there was one last step in here where we basically just consolidated these two terms. Nothing fancy there. All right, so we're going to try to get all the terms with dy by dx on one side. We're going to try to solve for it. So starting here, I think what we'll do is we'll take this piece here and move it to the left, and then we're going to take this piece here and move it over to the right. It doesn't really matter how you do this, it's just that one way or the other, you've got to get all the dy by dx's onto one side, and everything that doesn't on the other. After making that move, we should get something that looks like this. So now that all the dy by dx's are on one side, we can factor that out. And now it'll look like this. So you should be able to see that over here on the left-hand side, we've factored out dy by dx, which means we only have one more step to go here. All we need to do now is divide by this expression here. And that gives us our final answer. And I'm not going to bother to try to do any simplification here. Our answer has y's in it, but I don't really care about that. We have an expression for the derivative, and that's good enough. So, that's all for now.